Well, anyway, thanks so much for inviting me to talk. And I'm going to talk about some things that I'm really passionate about, namely philosophy and artificial intelligence. I just want to say ahead of time, kind of the ideas that I'm going to share in this presentation aren't original to me. I don't want to take credit, but I'm kind of bringing together a lot of different ideas from other philosophers and things that I think are very, very plausible and very interesting. Part of this presentation, I'm just going to go through 3 different philosophical positions, kind of lay them out, talk a little bit about consciousness and intelligence in computers, and then I'll just present a few philosophical arguments. That's it. So, 3 positions. You can think of kind of the history of philosophy of artificial intelligence as kind of examining 3 different positions. And I'll just call them for now position A, B, and C. And they are responding to 2 different questions. One question is, could we make an artificial machine that is conscious? And the other question, which is different, but only subtly so, is, could we make a conscious machine through computation alone? Now, position A says yes to both of these. Of course, if you say yes to the bottom one, the top one will follow. They believe that just through computation alone, we could make a conscious machine. The second position, position B, would claim that we could, at least in theory, create an artificial machine that is conscious, but a computer is not enough of a machine to ever get us there. So that's position B. And then position C would just reject that we could make any sort of artificial machine in any sense. So just to go a little bit deeper into these 3 positions, the claims of position A are that 1, brains cause consciousness, the brain is a computer, and that we will one day be able to program a computer to be truly conscious. These are some philosophers and thinkers such as Ray Kurzweil and others that hold to position A. And I want to show you a clip from a sci-fi movie that illustrates this idea of creating a consciousness through computer programming. Okay, so this is an image of a computer programmer. And he's typing on a computer, writing algorithms, making architectures, all this sort of thing, and he creates this consciousness.dat file, and it's stable, whatever that means. But this is the idea. Does anyone know what movie this is? Chappie. Yeah, it's Chappie. Okay, position B. They kind of share the same assumption as position A. Brains cause consciousness. They would argue that brains are machines, defined as anything that performs a certain function as a machine. And they just happen to be biological machines. And they would say that creating an artificial conscious machine is at least a logical possibility. They're not closing that off. It may turn out that it's impossible for some reason or another, but at least it's a logical possibility is what they would say. And then they would say that computation alone is not sufficient to create a conscious machine. Philosophers and thinkers that have argued for this position are John Searle, Sir Roger Penrose, who's a theoretical mathematician, Hubert Dreyfus as well. Here's a video that kind of explores position B.
Mirror data makes a man. A and C and T and G. The alphabet of you. All from 4 symbols. I'm only 2. 1 and 0.
Half as much, but twice as elegant, sweetheart.
Okay, who knows this movie? Yeah, Blade Runner 2049. So Agent K, played by Ryan Gosling, is a replicant. He's an artificial, synthetic, kind of biological person that was created kind of fully adult form. And he has this digital girlfriend named Joy, and Joy kind of is projected from this device that he kind of carries around. And according to position B, there's no objection to K being conscious because he has the built-in causal mechanisms necessary to produce consciousness. But Joy, since she is purely computation, could not be conscious. And there's an interesting part in the film where Agent K has this experience and he doubts that Joy ever was conscious, actually. So that was kind of an interesting point in the film that illustrates position B. One more clip.
We have her mind. Structured gel. I had to get away from circuitry. I needed something that could arrange and rearrange on a molecular level, but keep its form when required. Holding for memories, shifting for thoughts.
This is her hardware?
Wetware.
So wetware is a term taken directly from the philosopher John Searle's writings. They actually interviewed a lot of philosophers in the making of this film. And this idea of wetware is that it's something that actually has the causal properties necessary. It's above and beyond computation, so to speak. And so this would be an example of creating an artificial conscious machine that was more than computation. So this also fits well into this position B that I'm talking about. That's the movie. That's the robot. Position C. Okay, so the claims of position C are that consciousness cannot be created artificially, either because it's just not part of the physical world, or because it simply can't be explained mechanically or computationally or anything like that. Descartes and Plato are two thinkers that come to mind here. A couple more distinctions I want to make that really help illustrate these positions. There's a distinction we need to make between simulation and duplication. So you can imagine two different robots and they behave exactly the same, but one of them is conscious and one of them is not. So simulation refers to merely imitating or mimicking the outward behavior of a system. Okay? So it's not the real thing, it just looks like it. Duplication refers to creating the real thing by duplicating all of the relevant causal processes of a system. Okay? So even though we may not be able to tell them apart, there's very different things going on here, and so we have to make that distinction. In the case of duplication, it really would be conscious and intelligent. In the case of simulation, it'd only be pretending. We also use the terms artificial rather ambiguously. In one sense, it's referring to things that are not real, only an imitation, like this beautiful imitation butter here. And it also refers to things that are real, but just not produced naturally, such as artificial diamonds, which, so I read, are made of pure carbon, have the exact same molecular structure. They are real diamonds, but they're just not produced by natural geological processes. Okay, so artificial it is ambiguous because it can either mean not real or not natural. There is also a distinction in the literature between weak AI and strong AI. These are not categories of machines, but they're theories or claims about computers and what computers can do. Strong AI, in the sense in which it was first written by the philosopher John Searle in 1980, it really is the claim that computer software plus hardware alone is sufficient to create consciousness. Weak AI is the claim that computer software plus hardware alone can simulate human cognitive behavior. So weak AI just simply says, with computers, we could simulate anything about a person. So just to recap, position A holds that strong AI is true. They believe in strong AI. And of course, by definition, they also believe in weak AI. Actually, from now on, I'll just call position A simply strong AI. Position B and C, they would reject strong AI, but they may disagree about weak AI. Some thinkers, such as Sir Roger Penrose, for example, has certain arguments that says there's certain things that computers would never be able to simulate about a human behavior. So for example, if any of you know from computational theory, the halting problem, he shows certain examples of where humans can tell when a program in a certain situation would stop or would halt, but it is proven through computational theory that a computer could never do that sort of thing. So that would be an argument that he would say that he would both reject strong AI and reject weak AI. Okay, so the summary so far. Position A is just strong AI, the idea that computers can be programmed to create consciousness. Position B is the idea that computers are not enough of a machine to produce consciousness. And position C says we could really never make a conscious artificial machine. So I'll just pause right there and just let you kind of ask any questions or any comments kind of about this first section. Yes?
You mentioned something about what has been proven by computational theory. What was that again?
Yes, so this is a problem that you study in computational theory. It's called the halting problem. And I'm not really the expert to ask about it. I did take this course. But it's basically this idea of knowing when a computer will stop. And in certain situations, you can prove that a computer can never actually solve the halting problem. And so that's kind of the basic idea.
Well, how does that serve as an argument against either weak AI or strong AI?
Well, because what he's saying is that weak AI says you could duplicate anything a human can do, anything at all. And so he simply is giving an argument there that says humans can tell when the computers can halt, but computers can't tell when the computers can halt. So there's a difference. Therefore, not everything that a human can do could be simulated. And I'm not saying that that's necessarily the right or wrong argument. I'm just saying that that is an argument that he offers. He also has many other arguments using Gödel's theorem and other things that I can't fully get into, but that's the basic idea. So, yes?
So is position B basically saying that, like, maybe with some other device you might be able to make consciousness, but like computers as we know them aren't capable of like creating that?
Exactly. Yeah.
Okay, so here's...
Yeah, you know about the halting problem.
Yes, I know lots about the halting problem. I mean, if I want to comment on that, I'll say that the main issue with the argument is we don't actually know if people can solve the halting problem.
Yeah, so in this case, because
we know we can, in specific cases, we can know of it, but we can also have machines that can solve it in specific cases.
Yeah.
But my question, so here's a position. So what if, so you believe you can't create sentience, like you can't, but you can cause it to become embodied within a system. Like you have a system, like there's just like a soul floating out there, and you have a machine, and then some natural process causes the soul to enter that machine.
Mm-hmm.
Where would you fall that as falling under?
Position C.
Okay.
Yeah.
So practically, even though it's technically position C, but you end up creating a machine that still ends up being sentient because, say, a soul flew into it or whatever, would it still practically fall into position C, even though it's technically in position C?
Yes. I mean, that does get into a little bit of nuance, and I think that what they're saying is the soul really is the source of the consciousness, and you didn't create that source.
Yeah.
You just created something that holds that, or something like that, you know. So if you believed in that this chair could be inhabited by a ghost or something, then you're saying, well, I made the chair, but that's not kind of really what is meant. Yeah.
When you talk about other kinds of machines that are not computers, could you talk a little bit about that? Because I know that, like, the brain, for example, functions electrochemically, and it's highly plastic, and so it's very different than a computer. I don't know what it would look like to manufacture a brain. And so are there other kinds of machines that you're talking about specifically?
No, this position is simply leaving open that possibility, not specifying or knowing that how we would even start to solve that problem.
Okay.
They're just leaving it open, saying we just don't know. They're not closing that off. They're not saying we could never do it, for example. So that's all they're really kind of saying there. Yeah. But the idea is that if you did have a machine that duplicated kind of molecule for molecule the same electrochemical processes, well, then they think that would also be conscious. That's the idea. Okay. All right. Let me clarify consciousness and computers. So before I talk about consciousness, I want to talk a little bit about definitions. So there's common sense definitions and scientific definitions. just let me give you an example of water for a minute. A common sense definition of water is that it's a clear, colorless, tasteless liquid. We can know certain properties about water. And really the common sense definition always comes before the scientific definition. And we all know the scientific definition of water is that it is H2O. The scientific definition is what we get at the end of prolonged study. We don't start off with the scientific definition. And so when we have scientific inquiry, what we're doing is we're using this as the target in order to further our investigation. It's the same thing with consciousness. A lot of people say consciousness is so hard to define. I think it's relatively easy to define. It's simply subjective states of awareness or sentience. It has a qualitative feel to it. And by saying that it's subjective, I'm saying that it is experienced by a particular subject. Okay? By saying it's subjective, it doesn't mean that it's a matter of opinion or something like this. So these states begin when one wakes up in the morning and continue throughout the day until one falls into a dreamless sleep or becomes unconscious. That's really the idea here. This definition of consciousness really doesn't say anything about free will. That is a separate issue. And I'm not really making any claims about self-awareness or self-conscious, being self-conscious, those sorts of things. But right now, I just want to give you this. This is our target. We don't have a scientific definition. Like I said, scientific definitions come at the end of prolonged study. So the target is the common sense definition that we currently have. A few more things to say about consciousness. I'm going to be using this word intrinsic kind of throughout the presentation. And intrinsic means belonging naturally to or essential to. And the idea here is that consciousness is an intrinsic property, or it is intrinsic to our neurobiology, as far as we understand it. And it just simply appears, at our level of understanding right now, that it is caused by biological processes in human and animal brains. I'm going to go on a slight little tangent here, but there are different aspects of consciousness that we could talk about. I'm just going to talk about one, which is called intentionality. Intentionality is the ability of the mind to be directed at or to be about objects or states of affairs in reality. And it's not to be confused with intentions. Intentions are just simply one type of intentionality. Intentionality is constituted by, at the most basic level, beliefs and desires and intentions. And it could also refer to our hopes and fears and expectations and perceptions and those sorts of things as well. Intentionality and consciousness go hand in hand. Because if consciousness is awareness and you're aware of something, your mind is directed at that thing. So this is a little more technical philosophy, but I want to kind of use it to talk about a few more points about consciousness. When we're talking about things in the world, we can talk about things in terms of them having an intrinsic form of intentionality or simply a metaphorical as-if kind of form of intentionality. Something that is intrinsically conscious or has intrinsic intentionality are things that literally have the capacity for intentionality. And as far as we're aware, we think that humans and animals have consciousness, but we don't know how far it goes down. We have good reason to believe that mice are conscious, but are termites conscious? It's kind of an open question. We really don't know how to answer that right now. So there's big open questions. But that's what we mean. We're meaning, you know, certain forms of life that intrinsically have that property of consciousness. When we talk, we could also use these words metaphorically as well. So we can talk about things as if they are conscious when they really aren't. So we can say that the car is really thirsty for gasoline, and we use that, and we all kind of know what we mean. That's not confusing to us. Say the goal of the planet is to survive, or the thermostat perceives a lower temperature, or these sorts of things. And these are all metaphorical ascriptions of it. And it's not a problem insofar as we keep the two definitions separate. But when we start confusing the metaphorical uses of the term with the literal uses of the term, there could be some confusion. Another important distinction here that kind of relates to the first is this distinction between observer independence and observer relativity. So you can kind of think of reality as existing of certain things that exist regardless of what we think or believe. These would be things like forces and atoms and molecules and those sorts of things, right? If all the conscious beings in the world, in the universe were to pass away, all these things would kind of still exist, regardless of our attitudes, right? There is one big exception to that, which I'll get in a minute. Observer relative facts, these are things that exist only because we think they exist. We treat them as existing. These are things like money, marriage, touchdowns, cocktail parties, religious sacraments. Okay, these are things that exist because we all kind of have a collective agreement on them existing. It doesn't mean that they're arbitrary just because they exist because we believe that they exist. But in the case of money, if we all stopped believing that those little green pieces of paper counted as money, well, they wouldn't be money anymore. So that big exception that I told you about was consciousness itself. So consciousness itself is an intrinsic property. So I'm conscious, regardless of what any of you think or believe. You may think I'm a zombie, but I'm not. That's an observer-independent fact. Okay, so sometimes we can talk about concepts in either sense, and it can cause confusion. So when we're talking about information in one sense, there's observer-independent information. That's information that exists intrinsically to us in the form of perceptions or memories or things like this. And then there's information that's observer-relative. So we say, oh, that book has some really good information in it. It doesn't mean that there's this information glowing and living inside of the book. It just means that when we look at the book, we know how to interpret those symbols. And so that is information relative to the way that we treat it. Does that make sense? Okay, and I want to make one quick point about language. Apologize if I'm going a little fast, but language is an extension of our biological pre-linguistic forms of intentionality. Don't really want to get into that for sake of time, but I just want to make a quick point about syntax and semantics. So these are two aspects of language. When we refer to syntax, we're referring to symbols and their organization. These could be ones and zeros. These could be sound waves, okay? Or certain letters that we string together in a certain way. And semantics is the meaning that we assign to the symbols. So the meaning of kangaroo, that is assigned to kangaroo. So when we're speaking language, we're actually speaking on two different levels, okay? I'm making noises out of this hole in my face, and then that would be the syntax. And at the same time that we're intending to do that, we also intend for those symbols to have a certain semantics, to carry with it a certain meaning. And so the meaning that we assign to the symbols is separate from the symbols themselves. Does that make sense? Okay. We can also talk about semantic states of consciousness, and these are just states of understanding, states of meaning, those sorts of things. Now, something only counts as a symbol if we give it that interpretation. So syntax itself is an observer-relative phenomenon. Okay, one more concept around consciousness, and this is the thesis of multiple realizability, which is this idea that the same mental state or mental property could be realized in a completely different physical structure. So it's not saying that consciousness is exclusive to the human brain. It just could happen to be the case that it could exist in an octopus brain, which is very, very different from human brains, or potentially in some sort of synthetic brain that we manufacture, or something like that. That's the idea of multiple realizability when applied to consciousness. Let's talk about computers. Computers are machines that do syntactical manipulation. They're manipulating symbols in a certain way. And the definition really comes from Alan Turing, and it's based off of the theoretical concept of a Turing machine. So a Turing machine is represented as a tape that has symbols on it. And there's a tape head that can move back and forth along the tape, and can read those symbols and can write new symbols to the tape. So there's also a set of instructions that could say, okay, in this state, if you read a 0, then write a 1 and move to the right. And then in this particular state, there's a different set of instructions. Read a 1, write a 0, and move to the right, just as an example. Okay? Now, a Turing machine is a model for all computation. From the book that we use in the computational theory course, this is just one passage, and that is trying to describe Turing machines, by which it says the input to a Turing machine is always a string. If you want to provide an object other than a string as input, you must first represent that object as a string of symbols. And a Turing machine can be programmed to decode that representation in such a way that it can be interpreted in the way that we intend. Okay. One other way that people think about computers is in terms of these different levels. There's the implementation level, the syntactic level, and the semantic level, or knowledge level. At the implementation level, this is referring to the hardware or the actual physics of the machine that we're creating. The syntactic level refers to the manipulation of symbols and strings of symbols and algorithms and information processing and those sorts of things. And so you can have different levels of abstraction of how those symbols are interpreted. And you can perform certain operations on those syntactical elements in the form of state machines and things like this. And then some people talk about this idea of a semantic level, where this is where there's concepts and beliefs, and memory, knowledge, understanding, and those sorts of things. Okay? An important idea about the implementation level is that the concept of multiple realizability applies to computers as well. So it could just be transistors, and it could be gears and cogs and levers. They could be made with hydraulic pipes and water running through them. One person wrote a paper in the 80s saying that you could create a computer with cats and mice and cheese, where the cat pulls on a gate, the gate opens, the mice comes out and catches the cheese, and the gates count as ones or zeros and all this sort of thing. Another prominent computer science wrote about how computational synthesis could be realized by groups of pigeons trained to peck as a Turing machine. Okay. It could even be carried out by the human mind. So you could just perform, like we did in the computational theory class on paper, the steps of a Turing machine. So all of you are computers that can carry out the steps of a Turing program. The point here is that the hardware realization to the computer is actually irrelevant. These gates work in different ways, but they're nonetheless computationally equivalent. That leads us to a certain property of computation that's a little bit odd and different from consciousness. And that is the idea of universal realizability. That a computer is a computer because we conscious beings actually give it that interpretation. To find out if something is a digital computer, you don't have to look for ones and zeros. Rather, you just have to look for something that you can treat as if it is a 1 or a 0. So a computer can be anything we want. The key point is that what is or is not a computer is purely a matter of observer relativity. So on the definition of computers given by Alan Turing, this chair is a computer. It just has a very simple program. Stay there, and it follows that program. Computation is an observer relative feature of reality. Okay, so just to recap. Consciousness refers to subjective states of awareness or sentience. That is an observer-independent fact about reality. Computers are symbol manipulation machines. That is an observer-relative feature of reality. So let's just pause there and see if you have any questions or comments. Yes?
Can you explain actually this slide a little better? I don't know if I understand the computers are observer relative. What does that mean?
Yeah, so that's what I was trying to go talk about when I was talking about observer or universal realizability.
Right.
Basically, the idea is that what is or is not a computer simply depends on our attitudes of how we treat it. Okay? So what is or not a computer, it relies on what we can count as a 1 or a 0. In the computers that we use every day, the commercial computers, we use transistors, okay? There's no 1s and 0s that kind of live inside the computer. We just say this particular voltage, for example, counts as a 1 and this counts as a 0. And we've engineered it in such a way, using proof theory, to give us the results that we want on the engineering level. And so that happens to be a far more useful form of a computer than cats and mice and cheese and strings and gates. Okay. So I'm going to go through a couple of philosophical arguments and then I'll wrap up. Just to recap, the three positions: position A, which is strong AI, position B, position C. What I want to give is two arguments that I find to be plausible and persuasive that give a critique of strong artificial intelligence. One could think of the basic picture of strong AI is something like this. Well, the brain has neuronal processes, and the brain causes consciousness, and consciousness is realized in neuronal structures. And computers have a certain implementation, and they have a syntactic level and a semantic level. And so couldn't you just simulate all of the different neuronal processes on a computer and create the same thing on a digital computer? That's kind of the picture that they have. Argument one. So the first premise is that computation is defined syntactically. Syntax is the shuffling of symbols using particular algorithms. Premise two says consciousness is constituted by mental contents. Specifically, it has semantic contents. And like I was mentioning earlier, semantic contents are those states of understanding or meaning that we have as conscious beings. Premise 3 says that the semantics is not intrinsic to the syntax. Therefore, computation alone is not sufficient to create consciousness. Here's kind of the idea. This all rests on premise 3. So the semantic level, anything that you're talking about in terms of understanding or knowledge, that actually is not intrinsic to the syntax. Instead, it is intrinsic to conscious beings standing outside of the computer, assigning certain interpretations to the outputs of the computer. Okay? So, this is where the Chinese room thought experiment comes in. Chinese room thought experiment says, imagine a person inside of a room. He does not speak Chinese. He has a bunch of symbols, and he has a rule book. And there's slots inside of the room, and people can put in messages in Chinese through the room. He'll look at the message. He doesn't understand a word of it, but he'll match the symbols, and he'll look at his rule book, which says, when you see this symbol, this symbol, this symbol, do this, 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 make this change here, do this, 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 okay? And he kind of follows all those rules by hand, and then he takes the symbols from his box, pastes them on a card, outputs outside the room. To the person standing outside the room, it looks like they've just talked to someone that speaks Chinese. The room has just passed the Turing test, if you know what that is. And, but all the while, the man inside of the room didn't understand any Chinese at all. He was just shuffling the symbols. He was just doing some syntactic operations. And so a lot of people have given objections to this thought experiment, but I think that what has a lot of longevity is the actual argument itself, saying that the symbols passed into the room, that's just syntax, but the semantics doesn't come, the meaning doesn't come from just shuffling the symbols, it comes from something else. Computers have kind of changed so much that the Chinese room thought experiment may not be as clear or as useful as it once was, but I think that the argument still has a lot of longevity. It still holds that you can't get the semantics from the syntax. Okay, argument 2. Argument 2 starts with the same premise. Premise 1, that the computations are defined syntactically. The syntax is not even intrinsic to the physics. Okay, this is observer relativity. So the conclusion is that computation is really, excuse me, computation is not discovered in the physics. Instead, computation is assigned to the physics. So that syntactic level really doesn't exist over there. That's also a thing that we simply just interpret the computer as having, but it's not, there's nothing there. The only thing that exists is the things inside of our heads that allow us to interpret it as having a syntax. Okay? All right. So physically speaking, there's just no such thing as a syntactic level or a semantic level. And something that doesn't exist can't act causally in the world. Therefore, what we typically call computers are not enough of a machine to produce consciousness. So this is the point that position B is making. Let me go through a few kind of questions. Can computers think? Famous person said, the question, can computing machines think, I believe to be too meaningless to deserve discussion, was Alan Turing. And he had something in mind, I think. There's a philosopher who's known as the greatest philosopher of the 20th century, according to the philosophers. His name is Wittgenstein. And he said that most philosophical problems were really just confusions of our language. And most philosophical problems aren't meant to be solved, but to be dissolved, by showing that they ultimately rely on some confusion of our language. And what he said was, but a machine surely cannot think. Is that an empirical statement? No. We only say of a human being, and what is like one, that it thinks. We also say it of dolls, and no doubt of spirits too. So I think that this is what Alan Turing had in mind, which is basically this idea of if you're trying to argue whether computers can think, well, you're just kind of arguing about what metaphors you want to accept and what metaphors you don't want to accept. So there's no scientific truth about matter, but a lot of people do make the claim that they can think. So let's see if we can analyze that a little bit further. Under one interpretation, you could say, could something be a computer and also think? Well, you're all computers, and you can all think. So, yes, a computer can think. Another interpretation of the question is, well, is computation by itself constitutive of or sufficient for thinking? And here the answer is no, because computation is defined purely as symbol shuffling, symbol manipulation. And it's not sufficient to cause thinking or intelligence or anything like that in the intrinsic sense. And nothing really happens beyond the level of the electronic circuits. Another question, is the brain a computer? Well, trivial result one, yes, since anything can be assigned to computational interpretation. But in another sense, no, it is not a computer, since nothing is intrinsically computational. So it couldn't be discovered that the brain or anything else was intrinsically a digital computer. So the question is really ill-formed. And saying that the brain isn't a computer, it doesn't really even rise to the level of falsehood. On the view that I'm presenting, that I personally find plausible, it's actually as incoherent as saying that the Mount Timpanogos is a prime number, or something like that. So why does any of this matter? Well, in one sense, it doesn't matter at all. If you're trying to create a self-driving car, it doesn't matter if it's intelligent or not, or what the stakes are. That's just a distraction. Okay? If you're trying to do real engineering with machine learning and artificial intelligence, these questions are irrelevant to those sorts of projects. In another sense, it kind of does matter. If you're trying to understand consciousness, trying to understand the world, trying to understand how the brain works, and you're relying on a specific type of metaphor for the mind in computation, well, it's important that we think about these things to make sure that we're thinking clearly and using clear language in order to avoid mistakes that we may potentially make. And in another sense, I think that it probably matters because I think the general public hears a lot of things about computers and what they can do, and there's probably a lot of unnecessary anxiety that that people have about computers taking over the world and all the scenarios in sci-fi movies and those sorts of things. So it's important to kind of try to add clarity as much as we can here. So what I've done is I've presented 3 different philosophical positions, talked about consciousness and computers, and I've presented some philosophical arguments for you to think about. And that's my presentation. Thanks. So, yeah, let's talk.
Yeah.
What philosophical position do you hold then?
Right now, today, probably, I think that philosophical position B is the most plausible to me, because philosophical position C typically rests on a form of dualism. Dualism is the theory of mind that says there's a spirit and there's a glove, And the glove goes over the spirit, right? And the spirit animates the body, and this is called dualism. And even though I am religious and believe in, believe in God and things like that, I do think that there are some philosophical problems with that view. It's not logically incoherent. It is a possibility, but it actually doesn't explain much, even if it is true. So I don't want to be pinned down, but at the moment, I find the position to be most plausible to me. Yeah.
Okay, so what if, like people often talk about like what if we make conscious machines, but what if we have machines that are already conscious, they're already sentient, and like by some moral philosophies that would mean that they have intrinsic rights. So do you believe that is a concern that we need to deal with?
If there was such a machine, yes. But I don't think that we're anywhere close to that. I don't think we've even started to really go down that route in any way. So it's kind of like Andrew Ng said. He said that worrying about machines becoming intelligent is kind of it's like worrying about overpopulation on Mars. And so technically, in a technical sense, I think that is a worry, but it's so far away that it doesn't really enter.
What if like our machines as they are, like they're sentient, we just have no idea. Like we think they're so far away, but what if we're actually already overpopulating Mars right now? We thought we were living on Earth, but we're actually on Mars, and like who knows what else is going on.
Mars isn't big enough for 3 rovers. This would be a great science fiction story, and I think there could be some very interesting things that come out of that thought experiment. It just doesn't seem like a real possibility to me. Yeah.
Well, so I work at the Utah State Hospital. It's the mental hospital here in Provo, and so it's interesting because you get so many people that to them their form of reality is totally real, is totally justifiable, right? I mean, their children are literally in the walls, like talking to them, So if our senses don't provide us with an accurate description of reality, then how can we actually truly know what reality is?
Yeah, so there is a position called nihilism. And nihilism has different forms. One says that life has no meaning. Another one says that there is no morality. And another form of nihilism is that you can't actually know anything about the world. And this is a big philosophical debate. I happen to think that it does rest on a specific philosophical error. I do think we can know reality directly. Now, that doesn't mean that there aren't cases where we're mistaken. Of course there are. But I think that we could kind of talk a lot about this, but basically, ultimately all of our concepts come from our percepts, and our percepts come from our sensations. And so therefore, if we're trying to undermine our sensations, well, we have to use concepts to do that. And so trying to reason our way into doubting our own sensations and perceptions actually is a self-refuting exercise, because you have to actually assume that it's valid in order to undermine it. So anyway, there's that. Yeah.
One thing I was thinking about is I think the distinction between semantics and syntax is kind of interesting, because I feel like you could almost, you could make an argument that semantics is an outward expression of inward, complex organization of syntax. You mean like if you have a knowledge graph that has this vast connection of all these different symbols that represents these contexts, I feel like that almost is semantic meaning in that sense, and I think that distinction is kind of hard to wrap my mind around.
People that object to kind of what I've just presented, they would say exactly the same thing. They say, well, semantics, syntax, those do actually exist in reality. And they talk about things like DNA and genetic code as if this is some intrinsic syntax. But the question that you have to distinguish is this an observer-relative phenomenon or an observer-independent phenomenon? Is it something that we simply treat as if it is a semantics because it's useful for us to treat it that way? Or is that something that's intrinsic to that knowledge graph in and of itself? And so that's the distinction that I really want to bring out and say, it's hard to really make sense of situations where there could be an intrinsic semantics outside of a conscious being. It's hard to even make sense of that term in my view. And so that I think is the key kind of distinction there. But, yeah. Yes?
I don't know if this is super in line with what Nick was just saying, but when you talked about the Chinese room problem, I was wondering like whether any of us have any real semantics or whether they're basically just like associations between a bunch of syntactic elements. And so like when you ask the guy who's like handing out the instructions and following the rule book, right? When you ask him, like, what does that symbol mean? He's not really gonna know because in a way, like in his world, that's the most primitive thing that exists. But if you ask us, like, what is an atom? Or like, what are these like increasingly subatomic particles? I feel like it just gets harder and harder for us to say anything besides like, it's just that. And so I don't know that any of our worldview isn't just associative between the primitive elements that are there. You know what I'm saying?
Mm-hmm.
And so that seems to be an argument for kind of like this internal syntax rather than meaningful semantics. And what we perceive as semantics are just like associations between things, which of course like a computer is capable of ultimately.
Well, so a couple things that I think are really interesting about that comment, and maybe so what I'm going to do is kind of talk about those in frame in light of these sorts of arguments. In one sense, there is no syntax in the mind, except for when we're consciously being engaged in actually looking at creating syntax or doing something like that. There's no language of the mind because that itself would be an observer relative attribution of the behavior of the neurons. And so I don't think that there is actually any sort of syntax going to mind. What there is just some sort of biological process that gives rise to consciousness. And then we consciously can go through the steps of doing that. To your first point is, well, maybe syntax, maybe our conscious experiences, this isn't exactly what you're saying, but this is what other philosophers have said that are more in line with that sort of concern that you bring up. Some philosophers, such as Daniel Dennett, would say, well, consciousness, maybe it really doesn't even exist. Maybe it's just an illusion. Maybe all this experience that we have is just an illusion. And it really doesn't exist. And so really, there's just the same amount of understanding in the Chinese room as there is outside of it. That has kind of two issues with it. One issue is that means that we don't actually really understand what we're saying when we're talking. So just by bringing up that question, and if you're making that strong claim, then you don't even understand it. That would be the logical result. The other issue is that the concept of an illusion really relies on this distinction between appearances and the actual reality, right? And it relies on the distinction because we say that an illusion is when the appearances don't match reality. But that distinction is important. You can make that distinction for things like rainbows, and you can make that distinction for mirages, things like that. But you can't make it for consciousness, because where consciousness is concerned, if it appears that you are aware, or if it appears that you have understanding, then you actually are aware. Descartes said, I think, therefore I am. I think that really is true. Like, just the experience of consciousness means you're conscious. And so denying that is kind of tricky. Kind of tricky. So, yeah. Yes?
So on the subject of syntax, I think they have a counter argument. I think it's
this will be the last question.
To premise 3 in the arguments they had. So the way I see it, like our observer things are like an abstraction of something that's in the physical world. Yeah. So if there's something in the physical world exists and we describe it and we have a mental concept of it. But in order to have a mental concept of something, there needs to be something that's physical. So like with money, like if you look at the physical, you can see these objects we call money is being exchanged, and it causes other objects to be exchanged and people exchange it. So here's my counter argument. I think that in order to be able to abstract a physical process into an observer one, there needs to exist an isomorphism, is what it's called mathematically, between the physical set and between the observer set. So even though we can arbitrarily assign computational models of things, there still needs to be some underlying complexity in order for us to even be able to make that assignment to it. So, and without that complexity, we can't say that something is a computer. So there's still something that's real and physical behind it.
Yeah, absolutely. There is something real and physical behind it. It would be really hard for us to assign the function of money to the air, for example. You know, there does have to be something physical kind of behind it. And in the case of computers, we have we have the operations of the computer, right, that are kind of performing certain operations and functions. But ultimately, there's nothing above and beyond those. You have the electronic circuits; they're doing their thing, and we've engineered them in a really awesome way to give us interpretations that we want. But it doesn't go any higher than that intrinsically. So that would be kind of the argument there. So anyway, let's wrap up. Thanks, guys.